Good morning, my chemistry friends. I hope everything is going great for you. It may not have been totally clear how to do that fleece atom activity, so today I thought I'd give you an example so that when you're working on it today, maybe you could be more productive. If it was totally clear, I still think the examples might be helpful. So let's get to it. Today we're talking about predicting ionic bonds, and that's what you're doing with the fleece atoms, is predicting how many of each atom will form together. So our first example, let's keep it simple and react sodium with chlorine. So when you did this, you would have pulled out that sodium thing and you draw the Lewis dot structure for sodium. So you would do this, you would draw one dot here for sodium. It has one valence electron. And then also for chlorine, and you would look it up, it's group 7, so it has 7 valence electrons, 1 there, 2, 3, 4, 5, 6, and 7. And you know chlorine has a really high electronegativity, so it's going to be really tugging on electrons. Sodium has a low electronegativity, so it does not have much pull on electrons. And then during the reaction, you get this electron being pulled over to this way into the chlorine. Afterwards, you get this sodium who's lost an electron, and what you end up with when you draw it is an Na +1. It's lost one electron, now it's a +1 charge. And this chlorine, literally you move this electron from that fleece atom of sodium and you drag it across over here to chlorine, so that in the end you have a chlorine that has all of its 7 electrons plus that 1 electron from chlorine right there. So it has its 7 plus 1 extra one, so it's gained an electron. It is now a -1 charge. And what holds these guys together, so that little white salt crystal, this is table salt that you put on your french fries, yum. What holds them together in this bond is just as simply that this one's negative, this one's positive, and they're attracted to each other. So they are held together. And if we looked at it, it would look like this. Like here's a little sodium with a +1, and here's a little chlorine with a -1, and then next to that, that should be a -1, not a plus. I think I drew a plus. And then next to that is another sodium, Na plus, and then next to that is another chlorine, Cl minus, and then over here there's a Cl minus, and these are all attracted to each other, Na plus. So if you could zoom in and see it, it would look like this, and then Cl minus here, and then another Na plus, and this would keep going, alternating back and forth, and it would come out of the windows or out of the screen as well and into the screen and be like a chunk of sodium chloride, little salt crystal there. All right, and that's what that ends up looking like. I just drew it for you. So the final formula here is they're happy when one sodium reacts with one chlorine. The formula here is NaCl. It's a 1-to-1 ratio. Okay. Let's look at a more complicated one when calcium reacts with nitrogen. So I look up calcium. It's a group 2 element. So it's going to have, it's going to have 2 valence electrons, right? And then I look up nitrogen, and it's group 5 element. So it has 5 valence electrons, 1, 2, 3, 4, and then pair up for 5. So there are 3 sites here, 1, 2, 3 on sodium that has the possibility of adding electrons. And since I keep saying sodium, I apologize. This should be nitrogen. My apologies. So what's going to happen is, since this is real electronegative, it's going to rip electrons off calcium. It's going to rip one out off calcium, and that's going to turn calcium into a +1 charge and nitrogen into a -1 charge. But it's not done yet, because calcium's like, dude, I still have one more. Nitrogen says, no worries, I need more. So it pulls another one off calcium, turning it to a +2 charge and nitrogen to a -2. Now the problem is this nitrogen's not satisfied yet. It needs a full octet. So it's got to bounce around until it finds another calcium atom here, sitting here with its 2 electrons. And this calcium's like, dude, one more? No worries. That turns this to a -3 into this a +1. Now the reaction is not over yet. Nitrogen's satisfied. This calcium is satisfied. But this calcium says, dude, I need to get up one more electron. So it has to find another nitrogen out there. And it does. So this electron then goes to this nitrogen, making this a +2 and this a -1. Well, now calcium says, dude, I'm happy. But this nitrogen says, dude, I'm not happy. And the process continues, and it starts to feel like it will never end, except we notice that this calcium atom that this nitrogen now bumps into gives it 1 electron there, making it a +1 and a -2, and then gives this electron there, boom, making it a +2 and it a -3, and now all of a sudden everyone involved is satisfied. And what this tells us is that for calcium and nitrogen, you need 3 calciums to satisfy 2 nitrogens. So our final formula then is calcium, and we need 2 of them. Oh, that's a total mistake. We need 3 of them. Let's erase that. We need 3, 1, 2, 3 calciums for every nitrogen. I should say for every 2 nitrogens. So the formula for the calcium nitride, which is this compound here, is Ca3N, meaning we need 3 calciums for 2 nitrogens. Now you might be wondering, well, what does this look like? So remember before we had an NaCl, NaCl all the way across? Well, this one will be a little more complicated, and it's going to be 3-dimensional, but it'll look something like this. There'll be like a calcium +2, a calcium +2, a calcium +2, and mixed in here, like right here, is a nitrogen -3 and a nitrogen -3. And then the next one's going to be like a nitrogen -3 here. And then down here, there'd be a calcium +2 and a calcium +2 and a nitrogen here and a nitrogen here. And there's another calcium +3, +2 for this guy here, right? And then there's 3 more calcium +2s. 1, 2, 3. And this one's calcium. This one's calcium. And this one's calcium. And there's another nitrogen here for those 3 calcium. So there's 2 for these 3. There's another nitrogen here for those 3 calciums, 2. So you can see that this thing grows out this way. For every 2 nitrogens, there are 3 calciums, and it just keeps growing out in all directions into this crystal of calcium nitride. And that's what you're trying to do today. You're trying to come up with this with the fleece atoms. So you're going to put these 2 valence electrons here. You're going to put the 5 of them on the nitrogen, or whichever one you have, and you're going to actually pull it off. And you're going to pull this one off. And you're going to be like, oh, we're not done yet. I need to find another calcium. And you're going to put it here. And you're going to keep going until everyone is satisfied. Now, if you need help, ask Miss Heck today. She'll be able to help you. Ask the people at your table. Work collaboratively to figure these things out. I want you to work, say, for the next 35 or 40 minutes on this. And then afterwards, I'm going to actually have you read the background information and do the pre-lab questions for our next lab. I want to kick that lab off on Friday, so I want you to get really ready for it. All right, sounds great, my friends. Have a good day and enjoy the learning about ionic bonds. That's what we call an awkward pause. You're welcome.